Hi everybody, I'm Sajad Muradi and welcome to my video which is about the calculate statistic parameter in the language programming. And I will be exploring, and actually today I will be exploring how to calculate a statistic parameter using three different languages. In this lesson I will focus on learning how to use the gamma inverse function INV. Let's go to make explanation about the gamma inverse function. As you see, the gamma inverse function calculates the inverse of the cumulative distribution function CDF of the gamma distribution. With this function and give the alpha and beta, this function finds the value x such that the cumulative probability for a gamma distribution random variables. Actually, we have a problem scenario and simple example for all gamma inverse function. Problem scenario. We have a company produced light bulbs and their lifetime follow a gamma distribution with this condition. Shape parameter is alpha equals 2 based on the historical data, and scale parameter beta is 500 hours average time scaling factor. Actually, we want to find the time by which 19% of the light bulb will fail. In this session of the lesson, we will use the Matlab workplace to write our example code in the Matlab workplace actually, and I want to employ our code in this space. As you see, this is form of the Matlab workplace, and this is editor window and command window. Actually, for first time I want to write the CLC clear close all and run it to prepare all space and to write our code. So as you remember, we have an assumption for our example, and this is a parameter. So first I write a parameter, parameters, and first I define the p as a value, as a variable. Actually is the 0.9, which is 19th percentile, and alpha equals 2. As shape para, and the beta equals And in the next part I want to calculate time for 19% failure. Time as a variable equals, I use GAMINV function, which is defined in Matlab for the gamma inverse distribution, and this function have 3 parameters, and this is form of this function in Matlab. P alpha and beta. So first I run the section. If I write a time, we see the result, and in the next step I want to write and show the result always after the run this code. So this play result I use a fprint function, f nineteen of light or fail by that n, and next part is time. I semicolon. So this must change. Okay, and run again. As you see the result, so I change this and run again. This is true. 19% of the light bulbs fail by 1945 hours. In the another part of our lesson, I want to use the spider to write a Python code for our example. So first I import another library and write from site.state import gamma, and I write comment actually I run the comment for this para. I define p as a variable and write 0.9. So and alpha equals to shape par and beta is 500 as a scale in next part. I won't calculate time for 90% failure. And time as a variable, save the result of gamma function for in the time gamma dot f p equals alpha and scale equals beta, and in the next part I want to display the result. This play result, I use a print f 19% of light bulb fail by time colon actually 0.0 f so I run it. Actually we have a mistake here that need to be correct, and I add port actually port and run again, and here again this need to be correct, and the result is not result, we have the result, and as the result is 1945. In the next part of the education, I use Jupyter space to write Julia code. So firstly, I write using libraries distribution, using distributions, and run to check the error, and it seems that it's correct. Seems correct actually. So I want define parameter for, and p equals 0.9 as a ninth percentile, and alpha equals to 0.0. Actually, it's the shape and beta equals 500 scale param, and I print. Actually, run again these parts. It's correct, seems correct, and I want to print L P alpha and beta, and run again. So I have a mistake here, and is that, as you see, the result is, but I use a quotation here and here. Okay, and run. As you see, the result of this. And next part, I want to calculate correlate time for 30% failure. So I defined this to use a gamma distribution, gamma and brackets alpha and beta. So, and next variable is the time to one tile. So this and p and next step, I want to print and show this, and before that I must write this comment and display result and quotation 19% of right bulbs fail by actually I use that round time and it's equals 0 and hours that per point actually and run. We have a mistake. Actually we have a mistake here and that this need to correct and I must add T and run. As you see 90% of the light bulb failed by 1945.0 hours. Thank you for